Okay, I want to talk about Newton's third law before I do more complicated Newton's first law problems. It's really important that we understand Newton's third law. What Newton's third law says essentially is if you have two different things and one of them is exerting a force on the other, then what we find in nature is that the other always exerts a force on the one. In other words, all forces in nature always appear in pairs. So what Newton's third law tells us is what the relationship is between pairs of forces, between objects. In order to demonstrate this, I'm going to ask you to look at a slightly more complicated problem than we did in the last video. Instead of having one object sitting on a tabletop, I've got two objects sitting on a tabletop. I have a 2-pound object and I have a 1-pound object sitting on top of the 2-pound object. And so now I want to analyze this problem using Newton's first law, because here we have a system which is in equilibrium. First thing I'm going to do is I'm going to choose as my body the whole system, both boxes together. You can do this. You don't have to choose an individual thing. You can choose groups of things to be the body that you focus your attention on. So this essentially is the same as the problem we did in the last video, where there is going to be a normal force up from the tabletop and a weight down from the object. And so we have our weight, which is this way. So here is our weight, and this is a 3-pound weight, and so I'm going to call it the vector 3. Okay, it's a 3-pound weight. Okay, and we also must have a normal force, which we need to be sure that we understand. The normal force is the force that the tabletop exerts up on the body. Okay, so I'll call that n, and that's the vector n is the force which the table exerts on the 2-pound object. A little messy, sorry. All right, and of course what we know is that the magnitude of n is equal to 3 pounds. Okay. That's just like the problems we did last time. Okay, now I'm going to choose the 2-pound object as the body. What are all the forces on this guy? Well, there is his own weight, but his own weight is only 2. So I'll just call that the vector 2. Is there anything else in the universe which is exerting a force on him? And the answer is yes. There is this normal force, which is a force of magnitude 3, which is up. So this force that we found last time, this force 3, is equal to, this is n, and so this, I can just label this as the force n. Okay, it was the force on the 2-pound object from the table. Is there anything else? Well, since we know n is 3, there better be something else, and so there has to be some force down. Okay, like this, and I'm just going to call that. I'm going to call this force. Let me sort of indicate it like this. I'm going to call this the force that 1 exerts on 2. Okay. And you all can see that since these 3 have to add up to 0, that the force, the magnitude of the force F12 has got to be equal to 1 pound. Okay, now suppose that I look at the, choose the 1 pound object as the body. What are all the forces on that object? Well, there is some force up, which I will call F21. Okay. F21 is the force which the 2 pound object exerts on the 1 pound object, because those two are in contact with each other and exerting forces on each other. There is also, of course, the weight of this object, and the weight of this object is 1. So I'll just call this the vector 1. This is 1 pound. And that's all. Those are all the forces that there are on the 1 pound object. And so we can see that F that 2 exerts on 1 is equal to 1 pound. Okay. And now let's look at, not like that, let's look at this force and this force. Okay. So F12 points down and F21 points up, and they both have the same magnitude. And now let's once again remind ourselves what these guys mean. This is the force that 1 exerts on 2 by virtue of their contact. This is the force that 2 exerts on 1 by virtue of their contact. And so what I can write is that the vector F12 is equal to minus the vector F21. Okay. So this is sort of a sleight of hand derivation of Newton's third law. Newton's third law actually is a statement of an experimental fact. We always find that if one object exerts a force on a second, then the second exerts an equal and opposite force on the first. So let's be sure we're clear on what Newton's third law says, and we say this very carefully. Newton's third law states that if A exerts a force on B, then B exerts an equal and opposite force on A. This is often called action and reaction, and I actually don't like that terminology at all. And the reason is students often tend to identify any equal and opposite forces that they see in a problem as having to do with Newton's third law, which is certainly not the case. It's important to realize that the two action and reaction forces, if that's what you want to call them, are always on different bodies, never on the same body. So anytime you look at a single body, none of the forces will have anything in the world to do with Newton's third law. For example, our old favorite, an object sitting on a horizontal tabletop with the weight down and the normal force up. The normal force and the weight are equal and opposite forces, but that has nothing to do with Newton's third law. That's simply Newton's first law.